This video specifically addresses acids, namely weak versus strong acids. And what does that exactly mean for the solution chapter? How do we recognize an acid? In inorganic chemistry, the kind of chemistry that we focus on this year in honors chemistry, we know that acid formulas primarily begin with the hydrogen ion. We knew this, yes? So this we would name as hydrochloric acid. It's a binary acid. Here is nitric acid, an oxyacid. It's hydrogen bonded to nitrate. Sulfuric acid. We could have acetic acid. Oh gosh, we could just go on and on and on. There's just hundreds of different acids. Now, there are associated properties with something being an acid, along with something being a base. We'll study that later. But how do we define an acid? And the most applicable definition for us, an acid, and we'll learn this to come, it's called the Bronsted-Lowry definition, but an acid is a proton donor. We could also say it's a hydrogen ion donor. Well, where's this idea of a proton? Well, remember about atomic structure. So hydrogen. Hydrogen has one proton in its nucleus, and if it's neutral, then it has one electron outside that nucleus. And the most common form of hydrogen has 0 neutrons. So we just have one proton in our nucleus. Well, most often, hydrogen chemically behaves like an alkali metal, releases this electron, or we invest energy to eject it, and it becomes the hydrogen ion. And what is the hydrogen ion but a proton? A single proton. So these are one and the same. All right. The last video talked about acids ionizing. And that is the behavior of an acid when it interacts with water to form ions. So if we take HCl, have it interact with water. Okay, what do acids do? They give away a proton or the hydrogen ion. So this will give away, and then water takes it on. And then what we have left over with is the anion. So the more electronegative piece of our acid. Okay. Well, we have different types of acids. We have a list of acids that we call strong acids. HCl is one of them. Strong acids ionize 100%. Okay, so what does that mean? Well, if you would have a 0.5 molar HCl solution, and we imagine that, we have an abundance of water. Well, actually, the solution will not contain any HCl molecules because all of the HCl will push to create, remember we call this the hydronium ion, and then the chloride ion. So in solution, even though the bottle may read HCl, in all actuality, it's really 0.5 molar of H3O plus and 0.5 molar of chloride. For every one of these, I get one of these and one of these. It's only the law of conservation of mass, not the law of conservation of molarity. And we're just looking at our mole relationships. So in your solution, all of this becomes this. That makes these strong electrolytes. So if we put that apparatus with the light bulb a hydrochloric acid solution, the light bulb would light very brightly. they have a high concentration of ions relative to substances that are not strong electrolytes, like non-electrolytes. And remember, it's free-moving ions that make something an electrolyte. Okay, well, what are the strong acids? There are 6 that we need to commit to memory. And this will continue for the rest of our adventure in honors chemistry and into second year chemistry. We know we want to utilize the periodic table as an aid whenever we can. And just so we don't get the glare, I changed the light setting. Okay, we start with chlorine. I'm pretty sure that HCl is very popular as a common acid. So just start with HCl and then continue down your halogens, HBr and then HI. So we have 3 binary acids that are strong acids. That means they ionize 100%. We also have nitric acid, a popular lab acid, sulfuric acid, popular lab acid, and perchloric acid. These are the main 6. Now, in some textbooks, you'll see chloric acid added, but we're not going to include that. That's a little bit of a modification to where we're going. Okay, so these are 6 strong acids. If the acid you're given is not one of these 6, it's a weak acid, which we'll get to in a moment. Now, sometimes we say that this is protonated water because this hydrogen ion is a proton and water has been protonated. It's taken on a proton. But we also can say the proton has been hydrated because we know we can use the term hydrated with water. And so sometimes we'll see that kind of saying. Again, a hydrated proton, well, that's the hydronium ion. If a protonated water, that's not as common, but this is one and the same with the hydronium ion often. Okay, so before we get to weak acids, can we just say, okay, so what about HBr with water? Okay, well, we know this will give away the hydrogen ion if it's truly an acid, forming hydronium and then your bromide. All right, so if you're given an acid like HC2H3O2, it's not one of these 6, so we know it's a weak acid. Okay, weak acids partially ionize. They only ionize about 1 to 3%. So they create a much smaller concentration of ions. So if we would put the light bulb apparatus into a weak acid solution, it would only dimly light. Weak electrolytes. So you still have ions, but the concentration is low, so it's just going to dimly light the light bulb. So small concentration of ions. All right. Now, acetic acid is still going to be an acid. It's still going to give away the hydrogen ion. It is still going to make hydronium and then your anion from your acid. Okay, but how do we show a difference that it's weak, that it's only ionizing a minuscule amount? We put double arrows. So we're making these, but because, and we'll learn this to come, of the strengths of the acidic and basic species, in a solution of weak acid, you have much higher concentration of your acetic acid. So in comparison to the strong acid, if you would have 0.500 molar, you only get about 1%. And so that would be 0.005, wouldn't it? Let me just double check my math really quickly. Oh, for heaven's sakes, I knew I was in error. 0.0500 molar. And then you're getting a 1-to-1 mole ratio, so you would have the same. And so you're still going to have 0.450 molar of this. The grand majority stays together, very little amount of ions. Okay, what would be another example of a weak acid? How about hypochlorous acid? Not one of our 6 strong. Okay, so what will it do? Well, first we're going to have double arrows. Remember, you can just write them as like half arrows or full arrows. It's an acid, and all acids, if they're being acids with water, will create the hydronium and then the anion. But we know we're going to have very little amounts of these. So it's going to be a weak electrolyte. The same with, for example, HF. Be careful, because HF is hydrogen bound to a halogen, but that's not a strong acid. And so we're going to have our double arrows, and we'll make hydronium and then fluoride. Weak electrolyte, weak acid. All right, so that helps us. We need to know these 6. Probably the only one that we'll probably have to commit to memory is just this perchloric. If you write this a couple times, I bet you got it, especially if we use, the periodic table to help us, starting with HCl, then HBr and HI. So any other acid you'd be given, you will be given acids you will be able to recognize. They will have that hydrogen ion out there in the front. We need to understand strong versus weak, and how that leads to strong and weak electrolytes. Okay.